Hello crew, it's been a while since I've come to you sort of in person as we can get. And I just wanted to thank you all for being so patient as we work through some of the significant glitches for the semester. Your patience has been really appreciated. So, without further ado, I want to talk a little bit about decompressive stress and the lesson that we're going to be going through. And the contents are kind of an overview. We're going to talk about the atmosphere. We're going to talk again about gas laws, kind of briefly, and there's a real quick experiment that I want you to do, not in week 1, but in week 2. We'll talk about the operational limits of the human and things that we can do to stay safe in some of these extreme environments. So let's kind of take a peek here and see how it's laid out. Okay, we're going to start out kind of with our overview as we usually do and a look back. I've linked out some of the key terms and people for you. The rest of them you'll need to kind of go out and take a look on your own, get a little curiosity going in there. And our main objectives are, we're going to talk a little bit about the atmosphere and the risk that comes with each layer of the atmosphere. You're going to have to go out there and dive into that and do a little research on what's important about it. We're going to talk about the organ systems that are affected by changes in pressure. And there's kind of 2 types. We can either make bubbles in systems or we can trap gas, and you're going to learn which organ systems do what, how to best prevent decompression illness, why the bubble itself is important, and then we're going to talk a little bit more about the operating limits of the human system again, and describe one aircraft, spacecraft, or diving system and how it either prevents or treats decompression illness in terms of the gas laws. I'm going to let you expand that out and pick any kind of safety system that's going to be part of your writing for this week, your reflection. And so, in order to back this up, how are you going to do some studying? You're going to look at OpenStack's Chemistry Gases. There's a link to that. I want you to read, it's posted in the common files, Physiology of Decompressive Stress. This is actually one of the aerospace medicine textbooks. This is an older version of it, but decompressive stress hasn't changed that much. I want you to stop after you read gaseous diffusion. Don't read the whole chapter or try to. And then a really good FAA pamphlet on altitude-induced decompression sickness. So I'm going to jump ahead and go to kind of the rest of the layout here. And hopefully you discovered as you're scrolling through that you can get rid of this menu on the side by clicking here in the upper left, and that gives you more room to look. Okay. The other thing is the lab overview. I'm going to take you to that hopefully here. And basically you're going to do the PHET. You're going to use the gas laws simulator to run your experiments, and I've provided a link to this in Pilot as well. I realized in grading some of your previous work that it wasn't clear which ones to use in the past, so very clearly we're going to use the gas laws in PHET. So that'll open up here. Computer's running pretty slow today. So let's scroll on down. The other thing that you should notice is I provided flashcard activities, and those are important to help you kind of review the concepts that are behind what's going on. Takes you to the flashcard activities, and you're going to be looking at hypoxia, and these are curated just for this class. The atmosphere. We'll also take a look at a couple of other topics. Barotrauma, cabin pressurization systems. We'll talk a little bit about hypoxia as well. Okay. The other thing that I have done is linked to all of the graded activities that you're going to have to work on. So those are the graded activities, thought boxes and quizzes. That'll help you find them as you work through this and show you what we're going to do in pilot, because there are a couple of things that are a little bit different. So stand by and we'll be right back. Okay, crew, we're back. This is module 10, and now we're going to start applying some of what we learned to humans operating at extremes. So we've talked about the reading that you need to do. We've talked about the lecture that you need to go through, decompressive stress. There are 6 modules, or 6 lessons this time. That's another reason that we're going to do 2 weeks on this particular module. And here is the laboratory 12. Okay, it's not due on week 11, it's due on week 12, and it has to do with the gas laws, and I'll show you what we're looking at here. And this is using the PHET, like we discussed before, and there is a gas law worksheet that is linked that you should be able to download. And hopefully, I want you guys to try to do this fairly quickly. So what I want you to do, and when I say fairly quickly, is at least try to access it so we know if you have difficulties. You need to fill in all of these blank areas. So these are the components that you're going to manipulate in the simulator. That's either starting volume, temperature, starting pressure, number of gas particles. And you are going to manipulate that and then fill in these blanks. That's going to be your submission. I want you to look at how all of these are related. We talked about Boyle's law. Basically, we're talking about scuba diving, Charles' law, hot air balloons. As we ascend, we change temperature and we get more volume. Amundsen's law, but that's the one we've called Gay-Lussac's law. It's going to tell you why a can's going to explode in a hot car. And although we haven't talked about Avogadro's law, you need to understand that the number of molecules in a volume of gas is proportional. It's directly proportional. So the number of moles is directionally proportional to the volume. So the more molecules you have, the more moles, the molecules you have, the higher the volume. So hopefully that'll give you a direct proportionality. I want you to go through these questions, and then I want you to pay very close attention here on the new and uncertain. I want you to start thinking a little bit more about these labs. I'm not seeing that from some of your submissions, so I want you to pay attention to new and uncertain and submit those. That's going to be a big component of this particular set of labs. So hopefully this, and if you have questions, reach out to me, reach out to your fellow crew as you start working these. Now the other thing that I want to go back and review is the mission log, which is a little bit different this week. It's not due the first week, it's due the second week. That's why it says week 12. So the instructions are, I want you to look at the whole of the course. Now I don't want you to write from the very beginning, but I want you to bring in pieces from the very beginning of the course. And I want you to pick a type of survival equipment that interests you. Now you're going to have to go out and do some research on this. It can be an oxygen system, a pressurization system, a way of monitoring the hardware, or its human occupant, an oxygen sensor, a pressurization sensor, something along those lines. And your writing needs to include the following: a brief history of the system that you've chosen, how we use it today, at least one principle or gas law that we have studied to date, or another principle, not even just a gas law, and it could be thermodynamics, and it must be included and explained as to how it works with the system. And then an example of where the system has been used to save lives and how it accomplished that. And I want you to tie this all together. So think about what we've learned from the very beginning of the system, of the semester, when we were talking about aircraft systems and spacecraft systems and how humans interact with those systems, the physical principles, and now start bringing in the human system, as we've talked about the cardiovascular system, the pulmonary system. Now we're talking about changes in pressure. So bring all of that in. And I want you to make that an example of, I want you to make this a 500-word presentation, writing. It's reflective in nature. Think about what you're thinking about. At least 3 citations in APA format. And I encourage you to keep your creativity. Some of you have been very creative in how you've written your weekly mission logs. And I love that. I want you to make this your own product. This is your incorporation of information, and it needs to have your spin on it. But it also needs to be supported with data. And I recommend that you bounce your ideas off me well ahead of the due date. And the final part that's really important is if you meet the criteria, the submission criteria, I'll allow you to cut and paste this into your final mission log. I'm not trying to create more work for you, but I'm trying to bring your level of work up to where I know you are capable of providing that to me. Some of it may have been confusing because I doubt that in your other courses you've been asked to look at information in this way, particularly not scientific information. So get with me early and let's try to have some fun with this.